Thanks, Gary. Our next speaker is Dr. Cord Wissmann. Dr. Wissmann is the president of GeoPier Foundation Company and has led the company to a more than tenfold growth over the past 20 years with design, build, construction projects in more than 30 countries and 5 continents. Cord is the recipient of 28 US patents and has published more than 40 technical papers and is internationally recognized as a driving force in the field of geotechnical ground improvement. Cord holds a bachelor's and doctoral degrees in civil engineering from Virginia Tech and a master's degree from UC Berkeley. Cord, thank you.
Thanks, sir. I've got the lapel mic. Can you all hear me in the back? So Aaron asked me to come speak today about stuff that we do. And I asked him, I said, well, nobody wants to hear about, drilling holes and pounding rocks. But what they wanted me to do, my task today is to show how some of these innovative techniques can be used and overcoming some of the barriers for these kinds of things. But before we start, would it be all right if we just if I asked you some questions, we kind of change it up a little bit, make it a little bit more interactive? Is that okay with everybody? How many of you all consider yourselves to be geotechnical engineers? Who's a geotechnical engineer here? Oh, that's pretty good. And for, thank you. And for the entire group, how many folks consider themselves to be innovative? Who's innovative? That's pretty good. That's about half of us consider ourselves innovative. The other half, maybe not so much. Okay, now how many folks think that our profession, now this is the civil engineering, design and construction kind of profession as a whole, is innovative? How many people think it's an innovative profession? A few, okay. And so, I'm not sure, what I actually think about that. I actually think that we tend to be less innovative than we'd like to be. We'd like to be more innovative, but we have barriers to getting that innovation done. And in fact, I think that's the reason for this whole conference, right? Is to overcome some of these barriers, right? So that's kind of the purpose of the talk. I'm going to talk about some innovation. I want to take a little bit of a historical perspective, though. So historically, our profession in geotechnical and in civil engineering construction has been, frankly, quite innovative. It started way back 6,000 years ago with the Egyptians. And I don't know if you know the history of the Bent Pyramid. That's one of the very first pyramids built for the pharaohs. And that pyramid has 2 slopes to it. And the rest of the pyramids don't. But this is one of the first ones. It has a steeper slope at the bottom. You can see that on the left-hand picture. And then it flattens out. And it turns out that the forensic studies have shown that that pyramid failed. It had a slope stability failure, right? It went through the pyramid. It was too steep. And went through there, and not only did they have to flatten the slopes and forever and ever, amen, after that, but they also dug out the ground for about 20 feet, 6 meters below these pyramids from then on, because they wanted to preclude shallow instability. And that's how over excavation and recompaction was born. The Babylonians, about 2,000 years later, they started putting reeds in between their stones as they built their towers. Everybody remembers the towers of Babylonia, right? And how'd they get them so tall? Well, they needed some tensile reinforcement. The Chinese back 1,000 years ago, they were building that little wall that you can see from space. And they had some bad ground. And as they're crossing some of the bad ground, they used heavy tamping for ground improvement. And then more recently, in the 1930s and 40s, most of the innovations in our profession were really rooted in Europe, right? So there was vibroflotation from Germany and wick drains from Scandinavia. Soil mixing was actually invented here in the United States in the 1950s by a company called Intrusion Prepack. A lot of people don't know that. More recently, finite elements are, were really an innovative tool for us in our profession. Geosynthetics back in the 1980s, we didn't have that, and it was the environmental world that required that for us. Soil nailing more recently. Can you imagine building the things that we build today without these innovations? No, they're part of our stuff. So the innovations that we're looking at today, that you're looking at today, will be part of tomorrow's suite of technologies. And really what we're trying to do is get these things adopted a little bit faster and overcome some of these hurdles, right? All right, so Aaron wanted me to talk a little bit about our company. I'm like, oh, that's kind of boring. But he wanted me to explain maybe or tell the story a little bit how we innovated some things and how we overcame some of these barriers. So our company was founded in the 1990s by this crazy guy named Nat Fox. And this guy was, anybody see the Back to the Future movie, you know, with Charlie and Doc Brown? This guy was Doc Brown, guy with a crazy haircut and all of that stuff. And he came up with this innovative technology of drilling holes and pounding rocks a certain way, making the ground better, using that to support foundations. And to protect his business, he patented it. Now, how many people think that patents are good for our industry? A few. Okay, how many people think they're not so great? Nobody. Well, I think they're good because patents provide the impetus for companies like Chance and our company to go ahead and innovate some stuff and create some stuff and create that value for the consumption of society. Now, that value is usually consumed on the private sector first before it's consumed on the public sector. We're going to come back to that in a minute. But the population, the taxpayers, people who pay for things, they benefit from these things if they can implement these things. Okay. We expanded. We had lots of commercial expansion back in the early 2000s, I guess. Went over to Europe. We work in 30 countries and a bunch of continents. And as we went forward, we also realized that this dinky little simple foundation improvement technology worked really good in some materials, but not in others. And so we expanded our product lines, much like, Chance has expanded their product lines, and much like, anybody expands their stuff and into other technologies that help us do proprietary ground improvement and influence the market in a good way. And this has driven the sales and driven the benefit, you should say, I would say, particularly in the private sector. Right, because it's a private sector folks that have the ability to go ahead and compare an innovative solution like this with a traditional solution and not worry too much about the impediments towards contracting. I'm going to come back to that. Okay. So everything was great. We did have to overcome a lot of headwinds in the private industry. What's a geopile? Have you ever done this in my backyard before? Or how many jobs have you ever done in Maine? Our soils are different here than they are in New Hampshire. Seismicity, I remember talking to one guy in Southern California. Our earthquakes are different than they are in Northern California. Really, I'm not so sure that's the case. Is there a building code for this? I don't want to be a guinea pig. These are the kinds of things that you have to face when you develop these technologies in even the private sector. And the way you overcome these things is, number one is you got to know the mechanics. So Aaron talked about mechanics of understanding the design methods for CO2 injection, I guess, in the ground. That was pretty cool. And you got to know the mechanics. You got to do lots of testing. Aaron talked about that. And you got to go lots of steps towards convincing people. And okay, that's part of our job, no sweat. But the public sector is so much worse, right? I mean, because the folks in the public sector, they come up with other excuses. They're not excuses, they're reasons, And proprietary systems are unfair because if I spec your proprietary system, some people can't compete, and we have a need for compete. How many people see that in their specifications? Yeah, we all do. Our statutes require open bidding. I mean, that's just a simple reality, right? We have to get open bidding. But who's the biggest loser for all of this? And I would say the biggest loser is your taxpayers, right? Is the public sector taxpayers. And it's not because in all jobs, proprietary systems are the cat's meow. They're not. Sometimes the traditional systems are way better. But you're robbed of the opportunity to choose one versus the other. And it's the opportunity to go ahead and go forward. That's really where you want to get to. Okay. So how did we overcome this? So we do a lot of work in the public sector now. And when we do that by simply engaging the stakeholders in the public sector. Now, back in the early 2000s, FHWA had a program called High Tech. Anybody heard of High Tech before? A few people, okay? And High Tech was an evaluation thing, right? And they would put together a panel of representatives from about 10 DOTs, and then some esteemed academics. You know, we worked with folks from Iowa State, Virginia Tech, Kansas, Berkeley, and not Maine yet, but maybe in the future, Maine, maybe Rhode Island, you know, maybe some places here in New England as well. And these are, by the way, these are really famous people, you know, that we're working with, and really esteemed people. And you get together a panel, and they require to do some testing. And at the end, you know, after all of the criteria that you have to jump that they provide, then they'll write an evaluation report. So we went through this process. And by having that evaluation report, it doesn't get you a get out of jail free card, but it gets you an opportunity to have the conversation so that when the DOT official comes and says, you know, I'm not sure it's going to work, you can take this evaluation report and put them in front of them and say, okay, here's a panel of pretty smart people that say it's going to work. And so that's what you do. It cost us about between $250,000 and $500,000 to get all this stuff done. You know, so it cost us a lot of money. We were a small company at that time, so it was a ton of money, but it opened the doors for all kinds of things in the future. Now we have to do better than that. We have to do more than jump the hurdle of, is this system going to work for private and public projects? We also have to jump the hurdle of, how do you contract for proprietary systems or innovative unknown systems in a world that requires competition? And you really have to work with the contracting folks in the DOTs and the public agencies to do so. You have to figure out what's allowable in that particular state. Some states allow us to put multiple contractors and bid our system specified as our systems with multiple contractors to get competitive bids. Some states like Iowa says, okay, we're going to allow you to bid your system against something we consider to be, is traditional and somewhat equivalent on a design build basis. And some states say, okay, we're just going to let you do a VE alternative. And they're all good. And you just have to work with the state DOT and the contracting authority to figure it out. That's a homework that you got to do. Okay. At the end, you have to make sure you get the value you want. Hybrid specs don't work. They really don't. Everybody knows that, right? You know, you can't do a design build spec and a method spec and combine them together because you're not going to get the value that you want. You're just not going to. But performance specs with bumpers, you know, your system can't have less than this percentage, or it has to go at least this deep, or, you know, has to meet these criteria. They work. And so that's what I'd encourage people to do. So lastly, Aaron also asked me to provide a vision for the future. And I didn't do this well at all. Don't pay attention to that thing on the board. But I think the real issue here is, in the public sector, it's fear of failure. And the fear of failure was personal to the people who are specifying these projects. Because if the project doesn't go well, right, you know, it's their reputation, maybe even jobs on the line. And if we want to go ahead and tackle this problem in an industry kind of way, we have to address that fear of failure. I'll give you an example. In the private sector has the advantage of saying, I could take a low risk and low benefit alternative and compare that to a high risk, high benefit alternative. And I can compare those two and I can decide which ones I want to use based on my risk threshold. But in the public sector, it's either low risk or no project. And so we have to find a metric to allow public sector people to accept risk, not just in proprietary stuff, but in any innovative kind of delivery. how do you accept risk? And I think the only way we're going to do that is we have to treat, I think, our decision-making from a holistic perspective. The holistic perspective is what is the long-term 20-year benefit to our constituents for a suite of decisions? And I haven't figured that out. And you guys are a lot smarter than I am. You can figure that out. Anyway, I'm going to leave you with that, and really enjoy being back to Maine. I've been here in 36 years, so it's really great. So thank you all.